Okay, so here we go. Here's a question on true bearings. So I'm going for a walk in the woods. I start at my car and I walk 5 kilometers on a bearing of 160 degrees. All right. Generally, with true bearings questions, the first thing we need to be able to do is we just need to get a sketch of what the heck's going on here. So I'm going to start by drawing a line, and I'm going to call that my north line. I'm going to say that this is where my car is. And from my car, I say I walk bearing of 60 degrees for 160 degrees for 5 kilometers. Well, 160 degrees is going to be, I don't know, maybe somewhere right about there. That's 5 km. That is 160. Okay, so now I'm at this new point, and again, I'm going to switch directions at this point, so I need another north line. I'm actually going to extend these north lines just a little bit longer to prove a point about what's going on here. Okay, so at that point, it says I walk 7 kilometers on a bearing of 80 degrees. Okay. Let me just grab another color. So 80 degrees is going to be basically and that was 80 degrees and that was 7 kilometers. Okay, so now the question is asking me, at this point in time, how far away am I from my starting point? So in order to solve this, what we have to do, the thing that we're looking for, just to reconfirm what we're up to, is I am looking for this distance here. I'm just going to call it x for now. All right. So what we're going to do is we're going to do a couple of maybe sneaky things in order to find that. The first thing we are going to do is we're going to use some of the rules that we learned back in ninth grade when it comes to parallel lines. All of these north lines are parallel to one another. When a line like the green one crosses two parallel lines, what that means is that alternate interior, alternate angles like this, that has to be 160 degrees, just like it's 160 degrees there. Well, if that's 160 and this north line is a total of 180 degrees, well, if I cut out 160, this has to be 20 degrees right there. So this angle is 20 degrees, which means that at that point where those lines are meeting, I've got 80 plus 20 degrees, I've got 100 degrees right there. Well, now we're in business. Now we know that we've got 100 degrees, so now I'm just going to apply the cosine rule. The cosine rule says that c squared is the same as a squared plus b squared minus 2ab cosine c. Again, on an assessment, you'll be given that. You don't need to memorize it. So now I'm just going to substitute and plug and chug. So if I always do it like that. So if I make my substitutions, so I'm going to say 5 squared plus 7 squared minus 2 times 5 times 7 times the cosine of 100 degrees. That solution will give me my length or my distance from there. So just because I wouldn't expect you to do that without a calculator. Let's just do that real quick. So control square root of 5 squared plus 7 squared minus 2 times 5 times 7 times the cosine of 100. I'm in degrees. We're good to go. Of course, my calculator does that, so I just got to add a decimal. And what that says is we're about 9.28. So that distance away, x is approximately 9.28 kilometers. Oh, not degrees, kilometers. I can get that right. So that's part one of this question. It's always going to be part of the process is we're going to have to find one of the angles in the triangle and use that to find the other side. The angle that we're always going to find is going to be the angle at the first juncture or the first turn. So that's the angle we need to find, and then we're always going to use cosine rule to find x. Okay? Now, the bearing that I need to use in order to get back to my car, what that's going to be is I'm looking for the measurement from true north all the way to this new line that we've created. Okay? This is always going to be an application of the sine rule plus just a little bit of logic and common sense. To start with, and I'll do this in another color, doing this green here. Again, we have parallel lines, so I know that this angle has got to be 80 degrees, because it's 80 here, it's got to be 80 there. Okay? So now my job is to try to figure out this extra little bit of an angle that's right here, and my whole angle, my bearing, is going to be 180. That's from here to here, plus 80, plus, and I'm just going to call this theta. So now, to find theta, we're going to have to use the sine rule. Theta is the side opposite the 5 kilometers. We know that this is 100 degrees, and we know the side opposite the 100 degrees. So sine rule will work perfectly. So sine rule says sine A divided by A is the same as sine B divided by B. Doing my substitutions, sine of 100 divided by 9.28 is the same as sine of this theta we're after divided by 5. So what that means is that 5 sine of 100 over 9.28 is the same as sine theta. So using the inverse sine ratio, 5 sine of 100 over 9.28 is going to give me theta. So now, again, this is plug and chug. This is calculator work. So if I grab my calculator and I go the arc sine of, I'm going to forget all of these numbers immediately, 5 times the sine of 100 divided by, I'm going to use the exact value here. Checking that, this matches that, so I get about 32 degrees. So theta is about 32 degrees. Wow, that looks like 100, not a 32 degrees. So bringing this all together, my bearing is going to be 180 plus 80 plus 32, and that's going to be about, I'm way too lazy to do this by my brain, about 292 degrees. Now, just looking back at this and thinking about it, 292 is slightly more than 270, which my diagram may or may not be super accurate, but that tells me that, I mean, it would make sense that I'd be somewhere in the 270 to 300 range, because just thinking about the unit circle again, you know, if I come here, I've got 90, 180, 270, and this line here seems to be right around 270. Again, my diagram isn't hyper accurate. I've fudged the angles. But that's the general process. And I think if you can do that, you're going to be just great. Okay, good luck.